Hi, I'm Sean Gannon, and this is Minute Math, and today we're going to learn about radical equations, and we're going to solve each equation, but remember to check for extraneous solutions. So if I was given this equation, the square root of 3n equals double square roots here, square root of 4n minus 1. Well, I have a square root on both sides, but both of them are isolated, which is nice. So I'm going to square both sides. By squaring both sides in one step, I eliminate both of the square roots. Leaving me with 3n on the left and 4n minus 1 on the right. Now it becomes a very simple problem to solve. I'm going to subtract a 4n to both sides, leaving me with 3 minus 4n, which is a negative n, equals a negative 1. Well, if I divide by negative 1 to both sides, that leaves me now with n equals, well, negative 1 divided by negative 1 is a positive 1, because remember, negative n divided by negative 1 is a positive n. So now I'm done. N equals 1. Fantastic. So a problem that had two square roots in the beginning, right? First looked hard, but it actually was a fairly simple problem. But we still need to check for extraneous solutions. So I'm going to check right here. I'm going to rewrite my equation, 3n, don't need that big of a square root, equals square root of 4n minus 1. Now remember, I'm going to plug this 1 in for both n's here. So the square root of 3 times 1 equals the square root of 4 times 1 minus 1. Okay? Remember your order of operations, 3 times 1 is 3. 4 times 1 is 4. We have the minus 1 still underneath the square root. Square root of 3 I'm not going to change right now. 4 minus 1 is 3. They are equal, right? Square root of 3 is equal to 3. That's a true statement. Left and right are equal. I don't need to write what the decimal is or anything like that. I see that they're exactly equal. I can consider that a good enough check for me. So they're both same, confirming that n equals 1 is a true answer. So let's recap what we did. We had a square root of 3n equals the square root of 4n minus 1, left and right there. I had to square both sides. Both square roots were isolated already. That left me with 3n equals 4n minus 1. Subtracted 4n to both sides, just solving for n here. I had a negative n equals a negative 1. Divided by negative 1 to both sides to eliminate the negative, essentially. Left with positive n on the left and a positive 1 on the right. I had to check my work, so I rewrote the equation and then I substituted 1 in for n, my answer I got here, right, into both ends. Now be careful, order of operations, left not so much, 3 times 1 is 3, and then we're going to take the square root, which just leave us square root of 3. But here, 4 times 1 first. 4 times 1 is 4. Then we subtract the 1. And it's all underneath the square root, which is 3. Okay? A lot of students will subtract 1 minus 1, get 0, and then say 0, and then, oh, it doesn't work. Be careful with that. So, our 4 minus 1 is 3. So we have the square root of 3 here on the right, square root of 3 on the left. Left and right are equal. Fantastic. So we know there's no extraneous solutions, and n equals 1 is my final answer.